Hi everyone, welcome to ace.online. So myself Krishna Reddy going to discuss some expected questions from power systems. Okay, this ace preparation league. Okay, now let us start our session for today. Let us observe this first question. In this first question, he has given a radial distribution system. So if you observe, a radial distribution system is protected by using overcurrent protection scheme using CT with ratio 400/5. Relay is set to operate at 150% of full load current. What is asking to calculate is PSM of the relay if the fault current is 4800 amperes. So here we need to calculate the plug setting multiplier. So that is known as what? PSM. So how do you calculate the PSM? What is the relation for PSM? PSM is equal to fault current by CT ratio multiplied with relay pickup value. Okay, relay pickup value. This relation gives the plug setting multiplier value. Okay, if you observe the question, what are the values that are given, sir? So he has given the fault current as 4800 amperes. IF given as 4800 amperes in the question. Okay, CT ratio given as 400/5. CT ratio given as 400/5. Okay, and relay pickup value is not given in the question, that you need to calculate here. So if you observe, relay setting given as what? 150% of full load current. Okay, so here relay pickup value is not given. So how do you calculate a relay pickup value? Relay pickup value, how do you calculate? So we need to calculate the value of RPV, that is nothing but relay pickup value. How do you calculate, sir? Relay setting multiplied with rated current of relay, rated current of relay. If you observe the question, he has given the relay setting as how much? 150% of full load current. Okay, so relay setting is 150%, 150/100. What about the rated current of the relay? Here, rated current of the relay is also not given in the question. Rated current of the relay is also not given in the question. So whenever it is not specified, what you need to take? Where the relay is connected? If you observe CT, relay is connected where? Relay is connected to CT secondary side, yes or no? Relay is connected to CT secondary side. If the rating of the relay coil is not given in the question, by default, we need to take rating of CT secondary as relay coil rating. So CT secondary rating is what? 5 amperes, okay? So here, you need to take it as 5 amperes. So this is nothing but relay pickup value is how much? 1.5 into 5. So how much do you get, sir? 7.5 amperes. Okay, 7.5 amperes. So what is the meaning of this? Whenever the relay observes the current more than 7.5 amperes, the relay is expected to operate. Relay pickup value means the quantity above which relay is expected to operate is known as what? Relay pickup value. Okay, but he is not asking relay pickup value. What is asking here? PSM he is asking to calculate. Okay, so all values are known now. Now can we substitute here and calculate the value of PSM or not? Yes. So PSM is equal to current given in the question as how much, sir? 4800 amperes. 4800. by CT ratio is how much? 400 by 5. Relay pickup value just now we have calculated how much we got? 7.5 amperes. Okay, 7.5 amperes. So now try to calculate this PSM and post the answer, sir. Try to calculate PSM and post the answer here. PSM, try to calculate and post the answer. What is the value of PSM that you get? You get the value of PSM as what? Done? PSM is equal to 8. PSM will not have any units. Plug setting multiplier will not have any units. Okay. So this is the first question. So let us move to the next question. Now observe this. Identify the directional relays for the system shown. He has given two lines in parallel. There is one source. Now he is asking to identify which relays are directional relays in this question. So let us try to observe here. So this is the source. Load. So here first line is protected by R1, R2. So this relay is R1, this relay is R2. Second line is protected by relay R3 and R4. Now try to identify which relays are to be directional and which relays are to be non-directional. Okay. First let us observe during normal condition. Okay. During normal condition, what is the flow of current? Okay. So R1 observes source to load. No, direction of current will be from source to load. R1, R2, R3 and R4. All will observe in the same direction, yes or no? Okay. So this is the direction of current in the relays during normal condition. Now let us take the fault in any one of the line and observe the direction. So fault F1. So for the fault F1, what will be the direction of current in the relays? R1 will observe in the same direction, but R2 direction gets reversed. Okay. R1 observes in the same direction, but R2 direction gets reversed. R3, R4 will be same as normal current direction. Yes or no? Okay. This is the direction of currents in the relays due to the fault F1. Now let us consider the faults in the remaining section. Let us consider here the fault F2 in this section. Due to the fault F2, what will be the direction of currents in the relays? So R3 will observe in the same direction, but R4 direction gets changed. So R1 will be same, R2 will be same as normal current direction, R3 direction will be same, but R4 direction got reversed. So how do you identify which relay is to be directional and which relay is to be non-directional? So as there is a change in direction of current in relays R2 and R4, R2 and R4. So relays R2 and R4 should be what? Relays R2 and R4 should be directional relays. Okay. So relays R2 is directional relay and R4 is directional relay. Okay. And R1 is non-directional. R3 is also non-directional. Okay. So R1 non-directional relay, R3 non-directional relay, R2 directional relay and R4 is directional relay. So this is how we will identify. Generally the relays which are connected at the source end will be non-directional, far end of the source will be a directional relay. Okay. So answer will be what? R2 and R4 are directional relays. Let us observe the options. So R2 and R4. So option C is the right answer. Okay. I think got the idea how to identify the relay to be a directional or non-directional. Okay. First we need to observe the normal current directions, then consider faults in different sections and observe the direction of currents in the relays. Okay. Chalo. Let us move to the next question. a power transformer rated 132 by 66 kV, delta star connected. What is saying? Power transformer rated 132 by 66 kV, delta star connected, is protected by differential relay. Is protected by differential relay. CT ratio on HV side is 500 by 5. What is the CT ratio on LT side? Okay, LT side CT ratio is asking to calculate. Whenever you observe a problem on CT ratio, first identify what data is given. Okay, first let us try to examine what is the data given. He is saying that power transformer, what is the ratio? 132 by 66 kV, 132 by 66 kV. What type of transformer it is? Delta star connected. Okay, delta and star connected transformer. It is protected by differential relay. So what you will do? We will connect the CTs on either side. Primary of the CT directly carries the line current. Okay. Still what data is given? CT ratio on HV side is 500 by 5. CT ratio on HT side, it is given as 500 by 5. That is HT side CT ratio. What is asking? LT side CT ratio is asking. So what is the CT ratio on LT side? Let it be some capital Ix by small ix. So our target is to calculate this capital Ix by small ix. Okay. Now let us try to observe this. Okay. How to solve, sir? Let us examine. So whenever the power transformer is delta star, CTs must be connected in opposite configuration. Okay. Because in delta star and star delta transformer, there is a definite phase shift of 30 degrees. Yes or no? There will be a definite phase shift of 30 degrees. To nullify that 30 degrees phase shift, CT configuration should be opposite to PTR configuration. So here PTR is what? Delta star. CTs must be oppositely connected, that is star and delta. Okay, here the CT must be connected in star and here the CT must be connected in delta. Okay, and we need to connect this star point to this delta point and the relay coil should be connected in the middle. This is relay coil. So during normal condition, there should not be any current through the relay. During normal condition, there should not be any current through the relay. Now, our target is to calculate capital Ix and small ix. This value we need to calculate. Okay. For that, here the CT ratio on HT side given as 500 by 5. So here, if it is 500 amperes on primary side, secondary side will be how much? 5 amperes. Okay. The same 5 amperes will be in the line also, because in star connection, phase current and line current will be same. So for the current to be 0 in relay coil, so here what should be the current? 5 amperes. Just a minute. So here, what is the value of this small Ix? So how do you calculate the value of Ix? This is the phase current. In delta circuit, I phase is IL by root 3. So how do you calculate small Ix value? That is 5 by root 3. Okay. Now what about capital Ix? How do you calculate capital Ix? That is line current of the transformer. How do you calculate? Transformer is a constant power device or variable power device? Transformer is a constant power device. Transformer is constant power device. Okay. So transformer is a constant power device. Now how do you calculate that one? How can you calculate? So if it is a constant power device, what do you get, sir? So root 3 times of V1 I1 must be equal to what? Root 3 times of V2 into I2. Root 3 gets cancelled out. Here V1 is how much? 132. I1 is 500. So 132 into 500 is equal to V2 is what? 66 into I2 is nothing but Ix. So here our target is capital Ix. So what will be the value of capital X? That is 1000. Capital X value is 1000 amperes. So we got both capital X and small x. So what is the CT ratio here? 1000 by 5 by root 3. So answer will be what? 200 root 3 is to 1. Can we write like this? Yes. 200 root 3 is to 1 is the CT ratio. Okay. This is a procedure to find the CT ratio. So in the problem what he has given? So power transformer rated. So power transformer rated 132 by 66 kV, delta star connected, is protected by differential relay he has given. So whenever it is delta star, PTR configuration is delta star, CT configuration should be opposite. So our answer is what? So here our answer is 200 root 3 is to 1. Okay. Right. Let's move to the next question. So if you observe this question, what he has given? Synchronous generator rated 125 MVA, 13.8 kV, 50 Hertz is protected by using a differential relay which operates when out of balance current exceeds 10% of full load current. If the neutral is earthed through a resistance of 2 ohms, calculate the percentage winding protected against earth fault. So by grounding with resistance, what is the percentage winding that has been protected? So how do you calculate? So first let us calculate percentage winding unprotected. Percentage winding unprotected. So how do you calculate the percentage winding unprotected, sir? That is nothing but relay pickup value. Relay pickup value multiplied with neutral resistance that is grounded by phase voltage multiplied with 100. Okay. So in this relation, this relay pickup value is to be calculated on primary side only, not on secondary side. Okay. On primary side we need to reflect that. Now let us observe what is the data again. So relay is said to operate when out of balance current exceeds 10% of full load current. Okay. What is the full load current here? 125 MVA, 13.8 kV. Okay. So let us try to substitute here 125 S by root 3 times of VL. No? So 10 by 100, 10% of that multiplied with S by root 3 VL. S is how much here? S is 125 MVA. 125 into 10 power 6 by root 3 times of VL. VL is how much? 13.8 kV. Okay. 13.8 into 10 power 3. Okay. This is the 10% of full load current. This is the full load current. S by root 3 times of VL. Multiplied with what is the neutral resistance that is grounded given in the question? Neutral resistance is 2 ohms. Okay. 2 ohms. Rn value given as what? 2 ohms divided by phase voltage. V phase is VL by root 3. Okay. 13.8 by root 3 into 100. Sorry, not 100. 10 power 3. Okay. Now if you simplify this, you will get the percentage winding that is left unprotected. Try to solve this. Percentage winding unprotected. Once you get this percentage winding unprotected, we will get the percentage winding protected. Try to solve this, sir. So solve this and post the answer. So percentage winding unprotected. How much do you get? Okay. Just try to calculate this one. I think you will be getting as 13.12%. Okay. That is the percentage winding left unprotected. Okay. So, but if you observe this question, what is asking? percentage winding protected he is asking. So what will be the percentage winding protected? So percentage winding protected, percentage winding protected is equal to 100 minus, what is the percentage winding unprotected that you got? 13.12, okay, 13.12. So simplify this, how much do you get? So what is the percentage winding? 86.8%, okay, approximately. So this is how we need to calculate the percentage winding protected against earth fault. So in this relation, while you are using this relay pickup value is to be calculated on primary side, not on secondary side, okay. Now let us observe this question. 50 Hertz 13.2 kV generator is having an inductance of 0.012 Henry and capacitance of 0.012 microfarad. Calculate the maximum value of restriking voltage. What is the maximum value of restriking voltage? So for this, let us try to evaluate what is the restriking voltage first. What is the relation for restriking voltage? VRV. How do you calculate the restriking voltage? VRV is equal to active recovery voltage. ARV stands for what? Active recovery voltage into 1 minus cos of T by root LC. Okay. This is the relation for restriking voltage. So when it will be maximum? When this cos of T by root LC equal to minus 1, you will get the maximum value. Okay. When cos of T by root LC is equal to minus 1, we will get a VRV maximum. Now what is the VRV maximum value? What is the maximum value of restriking voltage that you get? That is nothing but 2 times active recovery voltage. 2 times active recovery voltage. So if we can calculate active recovery voltage, our problem is solved. So how do you calculate the active recovery voltage, sir? How do you calculate active recovery voltage? ARV is equal to K1 K2 V maximum sin phi. K1 K2 V maximum sin phi. So here, if you observe, armature reaction effect is not given, okay, not specified in the question. So by default K1 is 1, okay, as armature reaction effect is not given. And type of fault is also not mentioned. By default we will take it as grounded fault. So for grounded fault, first pole to clear factor K2 is also 1. What is V maximum? So this 13.2 kV is line voltage. So how do you calculate? 13.2 by root 3. This is phase voltage RMS multiplied with root 2. Okay. Maximum value is required. Phase maximum. Cos phi is not given. By default, what is the fault power factor? ZPF lagging. Yes or no? By default, what is the fault power factor? ZPF lag. So cos phi is 0, sin phi will be what? 1. So you will get it as what? 13.2 into root 2 by root 3 kilovolts. Okay. That is the active recovery voltage. Now what is VRV max? 2 times this one. 2 times active recovery voltage. 13.2 into root 2 by root 3 kilovolts. So try to simplify this and post the answer. So try to calculate what is the maximum value of restriking voltage. What is the maximum value of restriking voltage? Done. What is VRV max? How much? So you will be getting as what? 21.54 kilovolts. 21.54 kilovolts. Okay. That's how we can calculate VRV max. Now move to the next question. So observe this one. Single phase equivalent circuit for studying the transient recovery voltage when fault occurs at the circuit breaker terminals is shown below. So what is the average rate of rise of restriking voltage? What is asking? To calculate average rate of rise of restriking voltage. So what is the relation for average RRRV? So what is the relation for average? There is a relation for average rate of rise of restriking voltage. So how do you calculate, sir? The maximum value of restriking voltage, that is 2 times ARV by pi root LC, pi root LC. Okay. So here inductance and capacitance are given, but active recovery voltage is not given. So how do you calculate active recovery voltage, sir? ARV is equal to K1 K2 V maximum sin phi. K1 K2 V maximum sin phi. He has not specified about armature reaction effect, so take it as 1. Type of fault not given, by default grounded fault we will consider. VM, maximum voltage is how much? Here single phase equivalent circuit. V of t given as 11,000 cos 314t. Okay. So VM is what? 11,000. Okay. Cos phi not given. So cos phi is 0. By default fault power factor, if it is not given, cos phi will be 0, sin phi will be 1. Okay. So what is active recovery voltage? 11,000 volts. Okay. Don't multiply with root 2 because here it is directly maximum value. Okay. Now we got active recovery voltage as 11,000 volts. Inductance given 1 millihenry, capacitance given 400 picofarad. Okay. So 2 times 11,000 by root L value given as 1 millihenry, 1 into 10 power minus 3. Capacitance given as 400 picofarad, 400. If you simplify, you will get the active average rate of rise of restriking voltage. So try to calculate average RRRV. This is the average rate of rise of restriking voltage. Anyone post the answer, sir? Average rate of rise of restriking voltage. What is the average RRRV? So what do you get? You will be getting it as 11 kilovolt per microsecond. Okay, 11 kilovolt per microsecond. Done. Let us move to the next question. Observe this one. So what he has given? Average RRRV of a 132 kV circuit breaker is 10 kilovolt per microsecond with fault power factor of 0.8 lag. What is the average RRRV with a fault power factor of 0.66 lag, keeping the remaining things same? Okay, assuming remaining values are same, if the fault power factor is changed, what will be the change in average rate of rise of restriking voltage? That's what his question is. So let us observe what is the relation for average RRRV. What is the relation for average rate of rise of restriking voltage, sir? So how do you calculate? That is nothing but 2 times active recovery voltage by pi root LC. He is not speaking about any change in inductance or capacitance. L and C are assumed to be same. So only power factor got changed. So average RRRV is directly proportional to what? Active recovery voltage. Okay. So what is the relation for ARV then? Active recovery voltage, how do you write? So it is K1, K2, V maximum sin phi. So K1, K2, Vm are not changing, only the power factor gets changed. So what is your relation here? ARV directly proportional to what? Sin phi. Okay. So as ARV is directly proportional to sin phi, so by using these two relations, what we can relate? Average RRRV is directly proportional to what? Sin phi. Yes or no? So we can write average RRRV directly proportional to what? Sin phi. Can we write it or not? Average RRRV directly proportional to sin phi. Now by using that, can we solve this problem? Yes. So initially average RRRV, average rate of rise of restriking voltage in the first case given as how much? 10 kilovolt per microsecond. Here the cos phi value, cos phi 1 is what? How much, sir? 0.8 lag. Now we need to calculate average RRRV. Average RRRV. In the second case, we need to calculate if the fault power factor cos phi 2 is 0.66 lag. 0.66 lag. Okay. Now, it is average RRRV is directly proportional to what? Sin phi, not cos phi. So, how do you calculate here? Can you write like this? Average RRRV in the second case is equal to average RRRV in the first case multiplied with sin phi 2 by sin phi 1. Can we write like this? Because average RRRV directly proportional to what? Sin phi, not cos phi. Okay. So in the first case, what is the average RRRV? 10 kilovolt per microsecond. This is what given in the question. Sin phi 2 will be what? Phi 2 sine of, we can write like this, cos inverse of 0.66. Yes or no? Cos inverse of 0.66 by sine of cos inverse of 0.8. Okay. So if you simplify this, we will get the average RRRV required. Try to solve this and post the answer. So here average RRRV directly proportional to sin phi, sir, not cos phi. Okay. Should be careful while you are solving this. Try to get the answer. Try to post the answer, sir. What did so what is the average RRRV? I think you will get it as 12.5 kilovolt per microsecond. Okay. 12.5 kilovolt per microsecond. We will move to the next question. 132 kV circuit breaker. So if you observe this question, so what he has given, a 132 kV circuit breaker is used to interrupt magnetizing current of 20 amperes RMS at its instantaneous value of 12 amperes. Calculate the prospective voltage appearing across the breaker contacts if inductance and capacitance up to breaker location are 3 Henry and 0.01 microfarad. Okay. So what is the prospective voltage that is appearing across breaker contacts? Let us observe here. So how do you calculate this? Inductance is L. Let some stray capacitance CS. This is the circuit breaker. Now, the current that has been interrupted non-zero value. Current is not zero. What is the instantaneous current it has been interrupted? 12 amperes. Here I is given as 12 amperes. So there will be energy stored in the inductor. In what form? Electromagnetic field. So energy stored in the inductor will be what? Half Li square. Yes or no? There will be energy stored in the inductor in electromagnetic field. What is the property of inductor? Inductor does not allow sudden change in current. Inductor does not allow sudden change in current. So now there will be formation of capacitance across breaker contacts. Whatever the energy stored in inductor in electromagnetic field will be converted into electrostatic field, that is half CV square. Okay. So whenever the capacitance formation takes place, it builds up the voltage. Okay. So half Li square is equal to what? Half CV square. Yes or no? So what is the voltage that has been built up to? V is equal to I root of L by C. Here the value of current that you are substituting must be instantaneous value, not the RMS value. So instantaneous current that has been interrupted is how much, sir? 12 amperes. Okay. So now V is equal to I root of L by C is the relation. So current is 12 amperes. Here we should substitute instantaneous value, not the RMS value. Okay. So inductance given as how much? 3 Henry and capacitance is 0.01 microfarad. 3 by 0.01 into 10 power minus 6. So you will get what is the voltage that is appearing across the breaker contacts. Try to evaluate what is the voltage that is appearing across the breaker contacts. Try to calculate, sir. Calculate and post the answer. Done. This is nothing but 207.84 kilovolts approximately. Okay. So here by using this relation, here you may be confusing that you will substitute RMS value. No, we should substitute what? Instantaneous current that has been interrupted. Let's move to the next question. Now let us observe this question, sir. Okay. What he has given, in a 3-disc insulator string, the shunt capacitance is 1/10 of the self capacitance of the disc. Calculate the string efficiency. What he has given, in a 3-disc insulator string, shunt capacitance is 1/10 of the self capacitance. Calculate the string efficiency. So try to calculate. So here 3-disc insulator string is given. So let the self capacitance of the disc be some C. C be the self capacitance of the disc. Apart from this self capacitance, there will be shunt capacitance formation. So that is C dash. Okay. So let the voltage here be V1, V2 and V3. Now what is asking is K value, that is C dash by C, ratio of shunt capacitance to self capacitance given as 1/10, that is 0.1. What is asking to calculate? String efficiency is asking to calculate. So how do you calculate the string efficiency, sir? How do you calculate in this case? Percentage string efficiency is nothing but voltage across the string is what? V1 plus V2 plus V3 by number of discs are 3. Bottommost disc experiencing what voltage? V3. Okay, into 100. So here try to express V2 and V3 in terms of V1. So how do you write? You can write it as V1. V2 can be written as what? V1 into 1 plus K, and V3 can be expressed as what? V3 can be expressed as V1 into 1 plus 3K plus K square. Yes or no? V3 can be expressed as 1 plus 3K plus K square divided by 3 into V3 can be written as V1 into 1 plus 3K plus K square. This percentage we are expressing, we can multiply with 100. So V1 gets cancelled out. So we need to substitute a value of K here. K given in the question as 1/10. That is nothing but 0.1. So if you simplify this, you will get it as how much? This is equal to V1 gets cancelled out, 1 plus 0.1 plus 1 plus 3 into 0.1 plus 0.1 square divided by 3 into 1 plus 3 into 0.1 plus 0.1 square multiplied with 100. So you will get the string efficiency if you simplify this. Try to simplify and post the answer for string efficiency. Try to simplify and post the answer, sir. For string efficiency, how much do you got? What is the string efficiency here? If you simplify this, you will get, guess what? Anyone? How much do you get? I think you will be getting it as 86.76%. 86.76%. So the string efficiency is how much? 86.76%. Okay. Now let us move to the next question. So let us observe this question here. Observe this question. So what he has given, in a 3-disc insulator string, the guard ring is effective only for the disc near to the power conductor. Guard ring is effective only for the disc near to the power conductor. If the shunt capacitance is 1/10 of the self capacitance, then the string efficiency, calculate the string efficiency. Try to solve this problem. So here he is improving the string efficiency by using the guard ring. Try to calculate. So how can we establish here? So let us observe like this. So how many discs are there? 3-disc insulator string. The first one, second one, and third one. This is the power conductor. Okay. Self capacitance is C. Apart from this self capacitance, we have the shunt capacitance formation, that is C dash. This is also C dash. Here, in order to improve the string efficiency, he is using what? Guard ring. Okay. And what he is saying, guard ring is effective only for bottommost insulator disc. So that is only this one. Only first disc will experience that. So that means the current drawn by this C dash will be cancelled out, the formation of this C2 dash. Okay. It will compensate that. Now here the voltages, let be V1, V2 and V3. So as the guard ring is effective for bottommost insulator disc, can we write like this? V2 is equal to V3 but not equal to V1, not equal to V1. So we can establish the relation V2 is equal to V1 into 1 plus K. K value given as what? 1/10. K value is C dash by C. The shunt capacitance is 1/10 of the self capacitance, 1/10, that is 0.1. Now can we calculate the string efficiency or not? Yes, we can calculate the string efficiency. Percentage string efficiency is equal to, so what is the relation that you get? Voltage across the string, that is V1 plus V2 plus V3 by 3 times the bottommost insulator disc voltage V3 into 100. Okay. So here keep V1 as it is, V2 as it is. V3 can be written as what? V2, because it is same, no? V2 into 100. So if you simplify this, V1 plus 2 times V2 by 3 times V2 into 100. How do you write the value of V2 in terms of V1? V2 can be expressed as what? V1 into 1 plus K. Okay. So here we can rewrite it as V1 plus 2 times V1 into 1 plus K by 3 times V1 into 1 plus K into 100. Okay, V1 gets cancelled out. So what will be the string efficiency? String efficiency 1 plus 2 into 1 plus K value is 0.1 by 3 into 1 plus 0.1 into 100. Okay. So if you simplify this, you will get the string efficiency. So try to simplify this. How much do you get? The string efficiency as how much? Try to calculate the string efficiency and post the answer, sir. Yeah. By using guard ring, he has improved the string efficiency. How much you got? The string efficiency will be what? I think if you simplify this, you will be getting it as 96.9%, approximately 96.9%. Yes. Chalo. That means, so examine these two cases. In the previous case, without guard ring, same system without guard ring, what was the string efficiency? 86.76%. But if you are using the guard ring, that is effective for the bottommost disk only, the string efficiency is improved, yes or no? So no need to use the guard ring for the entire string. For bottommost 1 or 2 disks we can use, so that the string efficiency can be improved or not. Yes. Okay. Now let us try to observe this question. In a 3-core cable, the core to sheet capacitance is 0.1 microfarad and core to core capacitance is 0.3 microfarad. The cable is operated at 11 kV 3-phase 50 Hz. The charging current per phase in amperes. What is asking to calculate? Charging current per phase in amperes. So how do you calculate the charging current here? How do you calculate the charging current per phase? IC per phase is nothing but V by phase voltage by XC per phase. Sorry. XC per phase, capacitor reactance per phase. So we can write it as V phase into omega into capacitance per phase. That is nothing but 2 pi into F into phase voltage multiplied with capacitance per phase. So here, if you observe the question, per phase capacitance is not given. Core to core capacitance and core to sheet capacitance value is given. So now how do you calculate? Let us observe. Okay. So if you take a 3-core cable, suppose this is R phase, Y phase and B phase, and there will be a metallic sheet. And the sheet is at what potential? Ground potential. Sheet is at ground potential. There will be core to core capacitance. Let it be some C2 existing between these cores, C2. And there will be core to sheet capacitance also existing. Core to sheet capacitance, let it be some C1. So this C2, the core to core capacitance and core to sheet capacitance are given. Now from this we need to evaluate what is the capacitance per phase. So how do you calculate? So convert this delta to star. Okay. So if you convert delta to star, how the cable appears? If you convert delta to star, so C2 is replaced with what? 3 times C2. Okay. This is the neutral. Now the sheet is at ground potential. Yes or no? Sheet is at ground potential. Assuming that the cable is operating in the balanced mode, balanced condition. So sheet potential is ground, neutral potential will be also 0. So can we replace like this? Core to sheet capacitance can be also indicated here. With respect to neutral, you can indicate. As we are operating the system under balanced mode. Now what is the capacitance per phase? So capacitance per phase, how do you calculate capacitance per phase here? So capacitance per phase is C1 plus 3C2, that is core to sheet capacitance plus 3 times core to core capacitance. Okay, got the idea? Chalo. Now let us substitute here. So what is the capacitance per phase that you got? C1 plus 3C2, sir. What is C1? That is core to sheet capacitance. That is 0.1 microfarad, 0.1 microfarad, and the core to core capacitance is 0.3 microfarad plus 3 into 0.3. So 0.1 plus 0.9, 0.9. So this will be how much? 1 microfarad. 1 microfarad is the capacitance per phase. Once you know this capacitance per phase, can we calculate the charging current per phase or not? Yes, we can calculate here. So if you substitute, what do you get, sir? If you substitute the values here, that is equal to 2 into pi into 50 into, what is phase voltage? 11 kV is the line voltage. 11 by root 3 into 10 power 3 to capacitance per phase 1 microfarad, 1 into 10 power minus 6. So if you simplify this, you will get the charging current per phase. Okay, try to calculate the charging current per phase and post the answer. Try to calculate the charging current per phase and post the answer. The value of charging current per phase. Done? Have you got it? With the charging current per phase. Okay. Try to observe this. How much? 1.995 ampere. Okay. So this is how we can calculate the charging current per phase. But for solving this problem, you should have the basic idea how to calculate first the capacitance per phase. That is, if core to core capacitance and core to sheet capacitance are given, first convert that and then you can calculate. Done? Chalo. Let us move to the next question. In a 3-core cable, the capacitance between the two cores is 0.25 microfarad. When the other core is connected to sheet, what is saying? Capacitance. So observe this statement. The capacitance between the two cores is 0.25 microfarad. When the other core is connected to sheet, calculate the capacitance to neutral in microfarad. So how do we calculate the capacitance to neutral means? That is capacitance per phase. He is asking to evaluate. So how do we calculate? Let us try to observe this question. Okay. So if you observe a 3-core cable, there will be a metallic sheet. The sheet will be at ground potential. Okay. Now there are 3 cores. There are 3 cores. This is the first core. Let it be R. Second core Y. Third core is B. So there will be core to core capacitance. Let it be C2. And here also core to core capacitance. Let it be C2. And core to core capacitance is C2. And there will be core to sheet capacitance also exist, that is C1. This is C1. Okay. Now he has not given this core to core capacitance and core to sheet capacitance in the problem. What he is saying is, he has connected any one of the core to sheet. Suppose if I have connected this core to sheet, I have connected core B to sheet, then this C1 will not have any importance. And he has measured the capacitance between the remaining 2 cores. Let it be some Cz. Let it be some Cz. So how do you calculate the value of Cz? Now, how can we represent this circuit? So can we redraw like this? So this is core of R, Y and B. This B core has been connected to sheet. Sheet is at ground potential. Between R and Y, there is a capacitance of C2. Here you have C1 and here you have C1. Can you represent this core to core capacitance with respect to this C1 like this? Yes or no? This is C2 and the other C2 can be represented with respect to Y. Now this is the circuit and we are bothered about this CZ. How do you calculate the value of CZ here? Any idea? So if you draw for CZ, the circuit appears like this. So there is core to core capacitance C2. And if you observe, these two are in parallel, C1 plus C2, C1 plus C2. And one more circuit is in parallel, C1 plus C2, is C1 plus C2. And these two are connected in series. So these two are connected in series like this. Okay. Now can you calculate the value of CZ here? Can you calculate the value of CZ? Yes or no? So CZ value will be C2 parallel with these two. C2 plus C1 plus C2 by 2. Okay. So what is the value of CZ that you get? C1 plus 3C2 by 2. Okay. 2 times CZ is nothing but C1 plus 3C2. That means 2 times CZ we have already calculated in the previous problem. That is C1 plus 3C2 is nothing but capacitance per phase. Okay. So capacitance per phase is 2 times CZ. So if we observe the question, CZ value given as what? CZ value given as 0.25 microfarad. 0.25 microfarad. And he is asking to calculate the capacitance to neutral. So how do you calculate? Capacitance per phase, that is nothing but 2 times CZ, that is 2 into 0.25 microfarad. So how much do you get? 0.5 microfarad. Okay, I think you have got this problem. So simple, sir. So what he has given, connected any one of the core to sheet and measure the capacitance between the remaining 2 cores. So for that I have taken this B core has connected to sheet, so there is no importance of this C1. We can represent the circuit like this. And if you model the value of CZ, you will get C2 parallel with these two are in series, no? C1 plus C2 by 2. So the resultant will be capacitance per phase. This is a capacitance per phase, sir. This is capacitance per phase, C1 plus 3C2. Okay. Now, so he has given the value of CZ directly in the question as 0.25 microfarad. Now we can calculate the capacitance per phase using this relation. Okay. I think you got the idea how to calculate the capacitance per phase. Done. Once we have completed this, let us move to the next problem. Okay. So, let us observe these questions. A 3-phase, 3-wire overhead transmission line shown. Calculate inductance in millihenry per kilometer per phase. So here, sorry, this circuit I think is right. It is 3, 5 and 4. Leave it, sir. So it is 5 meter and it is 4 meter and that is 3 meter. So that's what the representation is required here. Just wait, otherwise you can model this. This is the given question. What is asking to calculate here? Inductance per phase. Okay, inductance per phase in millihenry per kilometer per phase. So how do you calculate the inductance per phase value? How do you calculate the inductance per phase? So what is the relation for inductance per phase? Inductance L is equal to 0.2 into ln of GMD by GMR. GMD by GMR. This will be millihenry per kilometer per phase. Okay, per kilometer per phase. So here they are not spaced at the corners of equilateral triangle. So how do you calculate the GMD of the system? GMD of the system is cubed root of what? X into Y into Z. Okay. So cubed root of, let X be 3, Y be 5 and Z be some 4. Okay. So you will get the value of GMD. This is the value of GMD. And what about GMR? How do you calculate the GMR? Here diameter given as what? 2.5 centimeters. So diameter given as 2.5 centimeters. Radius will be how much? Radius is 2.5 by 2. That will be 1.25 centimeters. 1.25 centimeters. So how do you calculate the GMR here? GMR of the system will be what? 0.7788 times of radius, that is 1.25 centimeters. Okay. So once you know GMD and GMR, can we calculate the inductance or not? Yes, we can calculate. Inductance L is equal to 0.2 into ln of GMD is what? Cubed root of XYZ, that is 3 into 4 into 5 that we got, and is 0.7788 into radius that we have calculated is how much? 1.25. 1.25. So yeah, this is in centimeters, that is in meters. Spacing given in meters, radius is in centimeters. So converted into meters, that is 10 power minus 2 we can write. So if you simplify this, you get the inductance value in millihenry per kilometer per phase. Okay, you get the value in millihenry per kilometer per phase. Try to calculate and post the answer. So what is the value of inductance per phase that you got? Try to calculate and post the answer. Try to calculate and post the answer, sir. Done. Anyone? 1.199 millihenry per kilometer per phase. So here the conductors are not spaced at equilateral spacing, 3 meters, 5 meters and 4 meters in triangular fashion, but they are not spaced at equilateral spacing. So then you need to calculate the GMD, that is cubed root of XYZ, that is 3, 5 and 4, and diameter given as 2.5 centimeters, 2.5 by 2, 1.25 centimeters is the radius. GMR we need to calculate, that is 0.7788 times of radius. Okay. Here this is in centimeters, GMR is in centimeters and GMD is in meters. Okay. Either you need to convert this meters into centimeters or centimeters into meters, but you should substitute the same units here. I have converted this into meters. Okay. I think you have understood this one. Let us take some short break for 10 minutes. Observe the next question. Okay. So here in this question, for a three-phase overhead transmission line shown, calculate the capacitance in nanofarad per kilometer per phase. He has given horizontal spacing, diameter of the conductor is 2 centimeters, 3.5, 3.5 and 7 meters. So how do you calculate the capacitance here? Capacitance per phase, how do you calculate? 2 pi into epsilon naught into epsilon r into ln of GMD by R. Here you will not take GMR, only the radius of the conductor is required, farad per meter. Okay. So for this system, what is the GMD that you can calculate? GMD that you can calculate is cube root of x, y, z. Okay, horizontally spaced. So what will be the value of GMD? Cube root of, let x be 3.5, y is also 3.5, z, the distance from R to B, let it be some 7. Okay. So you will get the GMD in meters. Diameter given as 2 centimeters, converted into meters, radius will be what? Radius will be 1 centimeter you will get. Radius will be getting as 1 centimeter, or you can write it as 1 into 10 power minus 2 meters. Okay. Now, substitute these values here. You will get it as what? 2 into pi into epsilon naught is what? 8.854 into 10 power minus 12. Relative permittivity, here the conductors are spaced in the medium of air. Relative permittivity is 1 by ln of GMD. GMD that we have already calculated. Cube root of what? Here 3.5, 3.5 and 7. 3.5 into 3.5 into 7 by 1 into 10 power minus 2. Because this is in meters and this is in centimeters, convert into meters. So this is farad per meter you will be getting. But what is the required value here? In nanofarad per kilometer per phase. So represent it in nanofarad per kilometer per phase. So what is its value that you get? Try to calculate and post the answer. Try to calculate and post the answer. Nanofarad per kilometer per phase. Try to post the capacitance per phase that you get as what? Right. 9.124 nanofarad per kilometer per phase. Okay, nanofarad per kilometer per phase. So in this question, he has given three-phase overhead transmission line. So here the horizontal spacing is given. So let this be x distance, y and z. Then first calculate GMD, cube root of x, y, z. This will be in meters. So convert either into centimeters or centimeters into meters. Diameter given as 2 centimeters. Radius will be 1 centimeter, 1 into 10 power minus 2 meters. Okay. So substitute these values in this relation. You will get the capacitance per phase. Okay. Now let us observe the next question. So here for a transmission line, so A value given as what is the required here? A value, D value given as 1 at an angle of 1 degree, he has given. B value given as 98 at an angle of 80 degrees, that is given. If the line supplies a load of 30 megawatt at 0.86 power factor lag and 105 kilovolts, determine the sending end voltage and regulation of the line. So what is asking to calculate here? The sending end voltage, Vs value he is asking to calculate, and what is the percentage regulation he is asking to calculate. So how do you calculate the sending end voltage? Vs, two-port network parameter equation. Vs is equal to what? AVR plus B into IR. So in this equation, this is per phase values you need to substitute here. Sending end voltage per phase you will get here per phase, and this you need to substitute as per phase current. Okay. So receiving end voltage given as what? 105 kilovolts. Okay. We are receiving end voltage. We are line to line given as 105 kilovolts. So what is the phase value that you get? V phase is VL by root 3. VR per phase value will be what? VL by root 3. 105 by root 3 kilovolts. So if you simplify this, what will be the value? 105 by root 3. Can you calculate and post the answer, sir? Can you calculate and post the answer? 105 by root 3. How much do you get? So I think if you simplify this and post the answer, you will get it as what? 60621.8 volts. Okay, this is the one value you have completed. This value you have calculated. A value already given, but IR not given in the question. So here B value is also given, but IR value not given. Receiving end current not given, but load given as 30 megawatt, power factor given as 0.86 power factor lag. So how do you calculate the value of IR here? IR value is to be calculated. So S is equal to, so not S, PR is root 3 times of VR IR cos phi R. So IR value is required here, PR by root 3 times of VR cos phi R. So here load given as what? 30 megawatt, 0.86 power factor. 30 megawatt given, 30 into 10 power 6 by root 3 into, what is VR? Line value 105 kilovolts, 105 into 10 power 3. Cos phi given as how much? 0.86, 0.86. So if you simplify this, you will get the value of IR. So try to calculate the value of IR and post the answer. Try to calculate the value of IR and post the answer here. What is the value of IR that you get? Anyone done? What is the receiving end current that you get? So I think if you get 191.81, so this is the amperes. Okay, but here angle is to be included, so we can write the value of IR as what? IR as, here the power factor given as what in the question? 0.86. So 191.81, angle is how much that you get? 30.86 degrees, because here power factor is given as what? Power factor given in the question as what? 0.86, no? So angle is to be included here, 191.81. So all values are known. Now can we calculate the sending end voltage? Vs is AVR plus B into IR. What is the value of A value given in the question as 1 at an angle 1 degree, 1 at an angle of 1. And what is the value of VR? VR phase value is how much? 60621.8. 60621.8 volts plus B value given in the question as 98 at an angle of 80. 98 at an angle of 80. What is the value of IR calculated? 191.81 at an angle of minus 30.86 degrees. Okay. So if you simplify this, we will get the sending end voltage, that is phase value you will be getting. Try to calculate this and post the answer. Try to calculate the sending end voltage and post the answer here. What is the value of Vs that you get? Vs per phase. How much do you get? 74492.8 at an angle of what? 11.83 volts. So this is the sending end voltage per phase. So what will be the line voltage? So Vs line to line is nothing but here phase voltage. V phase is VL by root 3. VL is root 3 times of Vs per phase. So root 3 times of, what is the value that we got here in the 74492.8? 74492.8. So how much do you get? If you calculate this one, the magnitude is how much? 129.025 kilovolts. You are getting the sending end voltage. So this is the sending end line to line voltage. Okay. He is also asking to calculate the regulation. So how do you calculate the voltage regulation? So asking to calculate the regulation, VR naught minus VR by VR into 100. Okay, no load voltage minus full load voltage by full load voltage into 100. So how do you, here VR naught, no load voltage is not known. So how do you calculate? VR naught value is what? Vs by A. Yes or no? VR naught value is Vs by A. So we can write the percentage regulation as mod of Vs by A minus VR naught by VR naught into 100. So here Vs value already calculated 129.025, and what is VR, sorry, here VR, no, not so here Vs value is already known, and VR value you required, VR line to line is 105 kilovolts. Okay, so here it is 129.025 minus 105 by 105 into 100. So if you simplify this, you will get the regulation. So calculated the regulation value. Done. What is the relation that you get? Anyone calculated? Grade as around 22.8%. Okay, 22.8%. So observe in this question what he has given. So he has given the value of A value, D value, and B value given, and the load parameters are given 30 megawatt, 0.86 power factor, and receiving end voltage is 105 kilovolts. That's what he is given. He is asking to calculate sending end voltage and voltage regulation. So we can calculate the sending end voltage by using the two-port network equation, that is AVR plus BIR. So receiving end voltage is 105 kilovolts, that is line to line voltage. Calculate phase voltage, and still we need to calculate the receiving end current. Load parameters are given. PR given as 30 megawatt, VR given as 105 kilovolts, cos phi given as 0.86. So here we need to include the angle, that is the power factor, so minus 30.86. So all values are known. We can calculate the sending end voltage phase value as well as line value. So once you know this, we can go for the calculation of regulation. So VR naught minus VR by VR into 100. So here A value is 1, that is given as 1. So Vs minus VR by VR into 100. Okay. That's what about this problem. Next, let us move to the next question. Observe this question. A 440 volts 3-phase distribution feeder has a load of 100 kilowatt. Load is how much? 100 kilowatt lagging power factor. At a lagging power factor with a load current of 200 amperes. He has not given about the power factor. Load is given as 100 kilowatt and 200 amperes. If the power factor is to be improved, he is going for improvement in power factor. First question what is asking is, what is the uncorrected power factor and reactive power of the load? What is the uncorrected power factor and reactive power of the load he is asking to calculate. And next, what is the new corrected power factor after installing a shunt capacitor of 75 kVAR? Okay. Now, how do you calculate? So, what is the value of load parameters? PR is √3 times of VR IR cos phi r. Okay. Let us first try to calculate what is the initial power factor at which it was operating. So, from this cos phi r value is required, that is nothing but PR by √3 times of VR into IR. Okay. So, what is the PR given here? 100 kilowatt, 100 into 10 power 3 by √3 times of VR. VR given as how much? 440 volts. 440. What is the current that has been given here? What is the load current? 200 amperes. 200 amperes. Now, what is the power factor at which initially it is operating? Try to calculate and post the answer. Try to calculate and post the answer. What do you get? Done. Try to calculate it and post the power factor. What you get? 0.656 lag. Okay. 0.656 lagging you will be getting. So, this was a first objective. Here if you observe, what is the uncorrected power factor, and is also asking to calculate reactive power of the load. What is the load reactive power? So, how do you calculate? He is also asking to calculate QL, that is P into tan phi that you get. P value is how much here? 100 kilowatt. 100 into tan of, that is tan of cos inverse of tan of cos inverse of power factor is how much here? 0.656. That's what you got. So, you will get the value of load reactive power. This is the reactive power drawn by the load. Try to calculate and post the value of QL. What do you get? Done. The value of QL that you get. Try to calculate and post the answer. What is the value of QL that you get? 115.055 KVAR. Okay. So, this is the load reactive power. Now, the first question, what is the power factor of the load and what is the reactive power drawn by the load? Now, what he is saying, power factor is improved by connecting a shunt capacitor of 75 kVAR. Okay. What is the new corrected power factor? What will be the new corrected power factor? So, by using shunt capacitor, there will not be any change in real power drawn. So, what will be the value of cos phi? This is equal to, what is the real power? That is 100 kilowatt, 100 into 10 power 3 by square root of, and what is the value of P? P square, 100 into 10 power 3 square plus, what is the QL? That is the 115.055, 115.055 into 10 power 3. And what is the KVAR supplied by this shunt capacitor? 75 KVAR minus 75 into 10 power 3 square. Okay. If you simplify this, you will get the corrected power factor after using the shunt capacitor. Yes or no? So simple, sir. Here cos phi can be write like this. That is P by under root of P square plus QL minus QC square. Okay. I have written that statement. Try to calculate this one and post the answer. Anyone? Done? Calculated, sir? Weighted as what? 0.928 lagging power factor. Okay, 0.928 lagging power factor. This is how we can calculate the power factor. Okay, chalo. Now let us observe this problem. 3-phase 5 kilowatt induction motor has a power factor of 0.85 lag. A bank of capacitor is connected to raise the power factor to 0.95 lagging. What is the determine the KVAR rating of the KVAR rating of the capacitor per phase, capacitor bank per phase. Okay, KVAR per phase he is asking. So how do you calculate Q of 3 phase? How do you calculate? P of 3 phase into tan phi 1 minus tan phi 2. So this gives the 3 phase reactive power. So what is the load given? 3 phase induction motor 5 kilowatt, 5 into 10 power 3 into tan of, initially it is operating at what power factor? It is operating at 0.85 lag. Tan of cos inverse of 0.85 lag minus power factor is to be improved to 0.95 lag, that is tan of cos inverse of 0.95 lag. So if you simplify this, you will get the reactive power that has been supplied by the 3-phase capacitor bank. That means total reactive power that has been supplied for 3 phases. You will get it. Per phase is required, divide with 3. Okay, done. Anyone calculated this one? Calculated, sir. Calculate and post the answer. Anyone done with it? So how much do you get? 1.455 KVAR. Okay, done. 1.455 KVAR. But this is 3 phase. If you observe, he is asking per phase. So Q per phase is 1.455 by 3. So divide with 3, you will get it as how much? 0.485 KVAR. Okay. So this is the reactive power that has been supplied by the capacitor bank. Now observe this problem. So if IC1 and IC2, these are nothing but incremental fuel cost characteristics of the plants are given. Limits are given as 20 less than or equal to PG less than or equal to 125 megawatt. For a power demand of 50 megawatt, find the optimal load sharing. Find the optimal load sharing. So he is asking to calculate how a load can be shared between the two generators. Incremental fuel cost characteristics are given. So what is the condition for economic scheduling? Condition for here losses are neglected because he is not speaking about any losses in the transmission line. Condition for economic operation, economic scheduling. How do you economically schedule the plants? This is one of the important area. So incremental fuel cost of the two plants must be same. df1 by dp1 must be equal to what? df2 by dp2. For n plants, all the incremental fuel cost must be same. So here IC1 is nothing but 0.2 P1, 0.2 P1 plus 40 given. What is df2 by dp2 given? 0.3 P2, 0.3 P2 plus 30, that is given. Okay. So we got one equation, that is 0.2 P1 minus 0.3 P2 is equal to minus 10. This is one equation. Okay. But here two unknowns are there. We need to calculate what? Both P1 and P2 we need to calculate. But here only one equation we have formulated. So how do you formulate the second equation? Use this PD. So power demand is how much? 50 megawatt. So we need to get P1 plus P2 is equal to PD. So P1 plus P2 is equal to what? 50. So you got the second equation. Okay. So first equation you got it as 0.2 P1. P1 minus 0.3 P2 is equal to minus 10, I think. This is the first equation that you got. 0.2 P1 minus 0.3 P2 is minus 10. Now solve these two equations. You will get the value of P1 and P2. Okay. So try to solve these two equations and post the values of P1 and P2. Try to solve this and post the answer. So try to get the values of P1 and P2. Anyone done with it? What is the value of P1 and P2? P1 you will be getting as what? 10 megawatt. Yes. P2 you will be getting as 40 megawatt. Okay. P1 is 10 megawatt, P2 is 40 megawatt. But observe here, what are the limits that are given in the question? Limits are given as what? 20 megawatt less than or equal to Pg less than or equal to 125 megawatt. So here limits are 20 megawatt less than or equal to Pg less than or equal to 125 megawatt. So here P1, if you observe, P1 is violating the minimum limit. P1 is violating the minimum limit. Okay. P1 is less than P minimum. In that case, what you need to do, sir? Set the generation of that particular unit to minimum value. Okay. Whatever the limit that has been violated, we need to adjust to that. Okay. So we need to set P1 to P minimum. What is P minimum here? 20. So P1 is to be adjusted to what? 20 megawatt. What about P2 then? When P1 has been adjusted to 20 megawatt, so what is P1 plus P2 must be equal to PD. PD is how much? 50. Okay. So P1 is 20 megawatt. Now P2 will be how much? 30 megawatt. Okay. So the answer is P1 20 megawatt and P2 is 30 megawatt. So whenever the limits are violated, so here P1 is violating the minimum limit. So whenever the limits are violated, you need to adjust the generation of that particular unit to the violated limit. If it is violating minimum limit, set it to minimum limit. If it is violating maximum limit, set it to maximum limit. Okay. So if they are within the limits, no need to adjust. Okay. If they are violating the limits, then only we can adjust this one. So now observe this problem. Incremental fuel cost characteristics of two units are given. IC1 given, IC2 given. Calculate the generation schedule of each unit for a Lagrange multiplier of 120 rupees per megawatt hour. So what is asking to calculate? So what is the generation schedule? Lagrange multiplier lambda given. So he has given df1 by dp1 as 0.4 P1 plus 30 rupees per megawatt hour, and df2 by dp2, that is incremental fuel cost characteristic of second unit, that is 0.3 P2 plus 20 rupees per megawatt hour. Okay. Now lambda value also given, lambda given as 120 rupees per megawatt hour, that is what he has given. What is asking? What is the value of P1 and what is the value of P2? What is the value of P1 and P2? So how do you calculate? What is the condition for economic scheduling of plants when transmission line losses are neglected? So when the line losses are neglected, what is the condition for economic scheduling of plants? Any idea? Condition for economic scheduling of thermal plants when transmission line losses neglected. So when you neglect the transmission line losses, what is the condition for economic scheduling, sir? So here what you get, df1 by dp1 equal to df2 by dp2 is equal to what? Lagrangian multiplier lambda. So we can use this condition and calculate the values of P1 and P2. Okay, let us evaluate here. df1 by dp1 is equal to lambda. So here df1 by dp1 given as what? 0.4 P1 plus 30. 0.4 into P1 plus 30 is equal to lambda given as how much? Lambda given as 120. Okay, lambda given as 120. You will get the value of P1 from this. Try to calculate. Similarly, df2 by dp2 is equal to lambda. What is df2 by dp2 that you get? 0.3 P2 plus 20. 0.3 P2 plus 20. 0.3 into P2 plus 20 is equal to lambda 120. So what is the value of P2 that you get in megawatt? Try to calculate the generation schedule here. Done. Anyone calculated the values of P1 and P2? Done, sir. P1, calculate P1 and P2 and post the answer. So here, this is a condition for economic scheduling. Okay. So calculate the value of P1 and P2 and post the answer. I think P1 you will be getting as 225 megawatt, yes or no? 225 megawatt, and P2 you will be getting as 333.33 megawatt, 333.33 megawatt. So what is the power demand here? Power demand, how do you calculate? PD is P1 plus P2. Okay, P1 is how much? 225 plus 333.33. So what is the power demand that you get? 558.33 megawatt. That's what we can calculate here. The generation schedule. Okay, in this question, what he has given, incremental fuel cost given and Lagrangian multiplier lambda value given, and he is asking to calculate the value of generation scheduling. Okay, done. Let us move to the next one. Now observe this. So IC1, the incremental cost of the first unit given, IC2 given, and P1, P2 given as 200 megawatt. Incremental transmission loss of the second unit given as 0.2. Calculate the penalty factors of the two units. So what is the penalty factors of the two units? You need to calculate here. So how do you calculate here? So whenever the incremental transmission loss and penalty factors are given, so we need to know what is the condition for economic scheduling when transmission line losses are considered and coordinated. So here what is the penalty factor of L1? L1 can be written as 1 by 1 minus incremental transmission loss of the first unit. So incremental transmission loss of the first unit is not given, so you cannot directly calculate the penalty factor of the first unit. So L2 you need to calculate, that is 1 by 1 minus incremental transmission loss of the second unit. So incremental transmission loss of the second unit is given in the question, 1 by 1 minus 0.8. So how much do you get? What is the penalty factor of this second unit? Try to calculate and post the answer. What is the penalty factor of this second unit that you get? Done. What do you get? Incremental transmission loss of the second unit is given as 0.2, no? So 1 by 1 minus 0.2. So how much you get? 1.25. 1.25. This is the penalty factor of the second unit, okay, right. But how do you calculate the penalty factor of the first unit? Here incremental transmission loss of the first unit is not given. Then how do you calculate? Use the coordinate equation. So what does it say? df1 by dp1 into L1 is equal to df2 by dp2 into L2. Okay. So this must be same. The product of incremental fuel cost and penalty factors of all the units must be same. So here df1 by dp1 is 0.15 p1, that is 0.15 p1 plus what 150 into L1 is equal to df2 by dp2 is how much? 0.25 p2 plus 175. 0.25 into p2 plus 175 into L2. L2 just now we have calculated as 1.25. 1.25. So P1 and P2 generation schedule is already given. P1 and P2 as how much? 200 megawatt. P1 and P2 given as 200. Okay. 0.15 into 200 plus 150 into L1 is equal to 0.25 into 200 plus 175 into 1.25. So from this you can calculate the only unknown is penalty factor of the first unit. So try to calculate the value of penalty factor of the first unit. Penalty factor of the first unit. Try to calculate and post the answer, sir. Try to calculate and post the answer. Penalty factor of the first unit. Second unit already we have done. First unit, how much you get? $1.5. Okay, right. So this is how we can calculate. This is a coordinate equation when transmission line losses are included and coordinated. Okay, if the transmission line losses are neglected, there is no need of these penalty factors. Let us observe this question. So what is given? If Vp minus Vq has given a distribution line, identify the minimum potential node. At which node you are getting the minimum potential? Okay. So what he has given? Vp minus Vq given as 3 volts. Now he is asking to calculate the minimum potential node. So how do you identify the minimum potential node? So let us assume like this. Let the current here be some Ix. Here what will be the current? Ix minus 10. Here Ix minus 30 you will get. Ix minus 60 you will be getting. Okay. Now try to calculate the value of Ix by applying the KVL here. Vp minus Vq is given as 3. That is Ix minus 10 into 0.1 is the resistance that has been given. That is Ix minus 30 into 0.15 plus Ix minus 60 into 0.2. Okay. From this, calculate the value of Ix. Try to calculate the value of Ix. So I have simply applied the KVL. Try to calculate the value of Ix. Done. Calculated the value of Ix here. Calculated. So how much you get? 45.55. Okay. 45.55 amperes. Now let us substitute the value of Ix in this network and observe. So here you will be getting it as 35.55 amperes is the current. Here you will be getting it as what? 15.55 amperes. But here you will getting the negative current, that is minus 14 point some. Okay. So that means which node is at minimum potential. So wherever there is a sign change in sign of current, we can say that that is a minimum potential node. So minimum potential node is what? So at which node you will get the minimum potential, sir? So answer is node S. Node S will be at minimum potential because there will be a change in sign at that minimum potential node. Got it? So I think you have understood this problem. How to identify the minimum potential node? First, try to calculate the current. So once you calculate the current, then substitute the value of current in this and identify where you are getting the change in sign. So once you get the change in sign, you can say that that will be the minimum potential node. Okay. Chalo. Now let us observe this problem here. Synchronous generator rated 100 megawatt 50 hertz. Regulation constant is 4%. Calculate the regulation constant in hertz per megawatt. So how do you calculate the regulation constant in hertz per megawatt? So what is the regulation constant given? R is equal to 4% given. So you can write it as 0.04 per unit, or 0.04 per unit hertz per unit megawatt. Okay, but he required the actual value. So how do you calculate the basic per unit value? Per unit value is equal to actual value by base value. So here you require actual value, per unit value multiplied with base value. Okay, so you can write this equation as 0.04. What is the frequency? 50 hertz base, and what is the power? By 100. Okay, so what is the value of regulation? That is 0.02 hertz per megawatt. Simple. Conversion of per unit to absolute value. Here you will get it as what? 0.02 hertz per megawatt. Okay. Now let us observe the next question. Synchronous generator rated 100 megawatt 50 hertz has a regulation constant of 4%. So here regulation constant is 4%. And if the frequency is dropped by 0.1 hertz, calculation of change in generation. So how do you calculate the regulation constant? R is minus delta F by delta Pg. So here you require the change in generation delta Pg. So how do you calculate? Minus delta F by R. So what is the value of R given here? R is given as 4%, 0.04 per unit. But you require the actual regulation here, 0.04 into base frequency is 50 hertz, 50 by 100, that is nothing but 0.02 hertz per megawatt. Okay. Now frequency is dropped by how much? 0.1 hertz. So that means here delta F we need to take it as minus 0.1 because it is dropped by how much? 0.1 hertz. So minus of minus 0.1 by regulation is how much? 0.02. So calculate the change in generation here and post the answer. calculate the change in generation and post the answer here. How much do you get? Done? Have you got this one? Okay. 5 megawatt. It is the change in generation. Okay. With this, let us conclude this session. So, thank you for your patient listening. So, there is an offer for you. So, you can avail 15% off on all GATE and ESC courses with this promo code KRIPS15. Okay, KRIPS15. You can avail discount of 15% on all GATE and ESC courses. Okay, thank you for your cooperation.